गुड मॉर्निंग 10th क्लास। आज हम मैथ का डिजी करेंगे 13 चैप्टर सरफेस एरिया एंड वॉल्यूम। देखो ध्यान से, एक बार आप डिजी से करने से आपको और अच्छे से रिवाइज हो जाएगा। देखो आज हम इसका करेंगे फाइंड सरफेस एरिया ऑफ कॉम्बिनेशन सॉइल। जो हम कॉम्बिनेशन सॉइल में ध्यान से
We've seen how to find the surface areas of three-dimensional shapes or solids, such as a cube, cuboid, cylinder, cone, sphere, and hemisphere.
सभी की शेप
But how can we find the surface areas of such solids?
ये इन्हीं का बेटा हमने जो कॉम्बिनेशन कर दिया, क्यूबिक, सिलेंडर, कॉन, तो हम इनका क्या करेंगे, एरिया एंड वॉल्यूम फाइंड आउट करेंगे। नेक्स्ट,
Notice that in each figure, a solid has been surmounted or lies upon another solid. In other words, these solids are a combination of one or more 3D shapes. For example, this solid is a combination of two cubes. In the second solid, a cone surmounts a cuboid. In the third example, a hemisphere surmounts a cylinder. Similarly, in the fourth solid, a cone surmounts a hemisphere. We can find the surface area of each of the composite solid by adding the surface areas of the individual solids that are combined to form the composite solid. So, to find the total surface area of the first composite solid, we add the lateral surface areas of both cubes, say cube A and cube B, along with the area of the top face of cube A and the area of the bottom face of cube B. Thus, we can determine the total surface area of the entire solid. Now, the second composite solid is made up of a cone and cuboid. So, we can find the total surface area of this solid by adding the curved surface area of the cone and the total surface area of the cuboid. Observe that the base of the cone covers some part of one face of the cuboid. Thus, we subtract that area from the sum of the surface areas of cone and cuboid. In the third example, the total surface area of the composite solid is the sum of the curved surface area of the hemisphere and the curved surface area of the cylinder, along with the area of one of the bases of the cylinder. Finally, in this composite solid, we find the surface area by adding curved surface area of the cone and the curved surface area of the hemisphere. Can you identify how to calculate the total surface area of each of these objects?
इनको ध्यान से कैसे इसका बना रखा है, कौन, सिलेंडर और हेमिस्फीयर, उनका हमने एरिया फाइंड आउट करना है।
This solid is a combination of a cone, a cylinder, and a hemisphere. We can find the total surface area of this solid by adding the curved surface areas of the cone, cylinder, and hemisphere. In the second solid, notice that the hollow or depression is in the form of a hemisphere. So, we can find the total surface area by adding the total surface area of the cube and curved surface area of hemisphere, and then subtracting the area of the base of the hemisphere. Let's learn how to calculate the surface area of a composite solid that is made up of a combination of solids of different shapes.
ये अलग अलग से आपको शेप दे रखी है, इनको ध्यान से देखें। नेक्स्ट, ध्यान से देखें इनको सबके अलग अलग से शेप।
We've seen how to find the surface areas of three-dimensional shapes or solids, such as a cube, A box is in the shape of a cuboid surmounted by a semi-cylinder. The dimensions of the cuboid are given. Find the total cost of the wood required to make this box if the cost of wood is 10 rupees per square inch.
देखो ये आपको क्यूबाइड का दे रखा है और ऊपर से आपका सिलेंडर शेप है, तो आपने इसका कॉस्ट है फाइंड द टोटल कॉस्ट ऑफ द वुड रिक्वायर्ड टू मेक दिस बॉक्स ऑफ द कॉस्ट ऑफ द वुड 10 रुपये पर स्क्वायर मीटर। देखो इसको ध्यान से एक बार अपनी अपनी कॉपी पर स्टेटमेंट भी लिख सकते हो। करें इसको।
To find the cost of the wood required to make this box, we need to find the total surface area of the box. This total surface area is the sum of the lateral surface area of the cuboid, the area of the base of the cuboid, the curved surface area of the semi-cylinder, and the areas of both the ends of the semi-cylinder. First, let's find the surface area of the cuboid. We put in the values for length, width and height of the cuboid and simplify.
पहले किसका निकाला आपने? क्यूबाइड का। थर्ड।
Next, we find the area of the base of the cuboid. As the base is a rectangle, we multiply the length and breadth of the base and find its area.
नेक्स्ट किसका है? बेस का। ठीक है। नेक्स्ट पहले हमने लेटरल सरफेस एरिया फिर हमने बेस का फाइंड आउट किया।
Now we find the curved surface area of the semi-cylinder. Notice that the diameter of the semi-cylinder is the same as the breadth of the cuboid and height of the semi-cylinder is equal to the length of the cuboid. Thus, we put in the values and find the curved surface area of the semi-cylinder. Next, we find the area of both the ends of the semi-cylinder. Each of the ends is a semicircle. Together, they form a circle and therefore, we multiply pi and the square of the radius to find the area of both ends of the semi-cylinder.
सभी के फाइंड आउट कर लिए। अब देखो सबको
Now we add all the surface areas to find the total surface area of the solid.
ये थे आपके टोटल एरिया।
Finally, we multiply the total surface area of the box with the cost of wood per square inch. Thus, we find the total cost of wood required to make this box.
ये था आपका सम जो हमने अभी सबका अलग अलग से एरिया फाइंड आउट किया।
A medicine capsule is in the shape of a hemisphere, attached to both ends of a cylinder. Find the total surface area of the capsule if its length of cylindrical part is 1.5 centimeters and diameter is 8 millimeters.
ये देखो आपकी बुक में भी ये सम कैप्सूल वाला सम है ना। हाँ, ध्यान से इसको देखें कि हमने इसको कैसे फाइंड आउट करना है।
The total surface area of the medicine capsule is equal to the sum of the curved surface area of the cylindrical part and the curved surface areas of both the hemispheres.
साथ साथ अपनी नोटबुक पे भी कर सकते हो बेटा। जल्दी से सभी जल्दी से करें। देखो क्या क्या हमारे पास एक सिलेंडर और हेमिस्फीयर।
Observe that the diameter of each hemisphere is equal to the diameter of the cylinder. We convert the units of the diameter into centimeters and find the radius.
ध्यान से देखो अब इसको डायमीटर mm में था, अब हमने इसको सेंटीमीटर में कन्वर्ट करके और उसका रेडियस फाइंड आउट किया 0.4 सेंटीमीटर। ध्यान से
Next, we find the curved surface area of the cylindrical part.
देखो ध्यान से किसका निकाला हमने? सिलेंडर का जो बीच का पार्ट था ना, उसका एरिया फाइंड आउट किया। ध्यान से देखें सभी। लिख भी सकते हो। नेक्स्ट,
Then we find the curved surface area of the two hemispheres.
हेमिस्फेयर जो साइडों में हैं इसके, उनका फाइंड आउट किया।
Now we add all the curved surface areas to find the total surface area of the medicine capsule.
इनको प्लस कर दिया। देखिए ध्यान से सम।
A cone of base radius 4.2 centimeters is surmounted on a hemisphere. If the total surface area of the solid is 203.28 square centimeters, find the height of the cone.
क्या फाइंड आउट करना? हाइट। ऐसे देखें सभी।
The total surface area of the composite solid is the sum of the curved surface areas of the cone and the hemisphere.
सभी अपनी अपनी कॉपी पे नोट डाउन करें।
To find the height of the cone, we need the radius and slant height. Since the total surface area of the entire solid and the radius of the cone are given, we put in these values. Also, note that the radius of the cone and hemisphere are the same. Then, we simply find the value of the slant height of the cone.
देखो हमने फाइंड आउट करना हाइट। अभी हमें एरिया फाइंड था हमारे पास, तो हमने पहले क्या एल फाइंड आउट किया 7 सेंटीमीटर। देखो ध्यान से, पाई आर एल फार्मूला कौन का और हेमिस्फेयर का 2 पाई आर स्क्वायर, दोनों के हमने वैल्यू लिख दी।
Now that we know the slant height and radius, we put in the values and find the height of the cone.
सभी करें अपनी अपनी नोटबुक पे। सभी ध्यान दें इस सम को। एच कितना आ गया हमारे पास 5.6 सेंटीमीटर। ठीक है, तो ये थे हमारे कुछ सम, जो हम इनको और भी सम इनमें से लिख सकते हैं।
To find the height of the cone. Now that we know the slant height and radius, we put in the values and find the height of the cone. A square pyramid is surmounted on a cube of side 5 centimeters. Find the surface area of the composite solid if the height of each triangle of the pyramid is 7 centimeters.
हाँ, ध्यान से एक बार इसकी स्टेटमेंट पढ़ें। सम को एक बार हम इसकी प्रॉब्लम देखें कैसे सॉल्व करते हैं।
The surface area of the composite solid is equal to the sum of the lateral surface area of the cube, the area of the base of the cube, and the lateral surface area of the pyramid, which is equal to 4 times the area of a triangle.
देखो सबके अलग अलग से पार्ट।
First, we find the lateral surface area of the cube. Next, we find the area of the base of the cube.
Side into side.
Notice that the lateral surface of the pyramid comprises 4 triangles. We know the height of the triangle and the length of the base, which is the same as the length of the side of the square. So we find the area of one triangle and then multiply it by 4. Finally, we add the lateral surface area of the cube, the area of the base of the cube, and the area of the 4 triangles that make up the lateral surface of the pyramid. Thus, we find the total surface area of the solid.
जल्दी से सभी अपने अपनी नोटबुक पे भी कर सकते हैं. अभी आपकी बुक में नहीं है, लेकिन फिर भी हम इनको सम को देख सकते हैं. अलग से हम इनको कर सकते हैं. देख ले सभी. सब अपने अपनी नोटबुक पर भी बना सकते हैं. ठीक है. अलग अलग से भी शो कर सकते हो इनको. सबका अलग अलग से जो आपने अभी सम की. समीकरण इनसे सम. समीकरण लिखें.
A vegetable is cut into 2 pieces. Does the volume of the vegetable change? No, even though the shape of the vegetable is changed, its volume remains the same. In other words, the volume of the vegetable is now equal to the sum of the volumes of the 2 pieces of the vegetable. Now look at this. The small metallic spheres are melted and a large sphere is formed. Here, the shape does not change, but the size and number of spheres change. So does the volume change too? If all of the small spheres are used to make the larger sphere and none of them is wasted, then the volume of the large sphere equals the sum of the volumes of the smaller spheres. When the liquid from this cylindrical container is emptied into this conical container without spilling a drop, does the volume of the liquid change? The volume of the liquid remains the same even though the shape of the container has changed. But what happens if a cube of metal is melted and then converted into another solid or shape, such as a cylinder? Does the volume still remain the same?
इसमें क्या बेटा आपको सभी में एक चीज से दूसरी चीज में कन्वर्ट करना. कौन को सिलेंडर में, सिलेंडर को कौन में, या स्फीयर में. देखो वैसे इसके सारे सम आएंगे.
Let's see what happens to the volume of a solid when it is converted from one form to another. We assume that no amount of metal is lost or wasted in this conversion process. The length of this metallic cube is 5 centimeters and volume is 125 cubic centimeters. The cube is melted and a cylinder is formed. So the volume remains the same. The diameter of the cylinder is 5.6 centimeters. And the height is 5.073 centimeters approximately. Hence, its volume is around 125 cubic centimeters. Thus, the volume of the cube and cylinder are the same.
दोनों के वॉल्यूम जो
Next, let's convert the cylinder into a cuboid. So, the volume remains the same. The dimensions of the cuboid are 10 centimeters, 5 centimeters, and 2.5 centimeters. Hence, its volume is 125 cubic centimeters. As you can see, the volume of the cuboid is the same as the volume of the cube and cylinder. Next, the same cuboid is melted and a cone is formed, and so there is no change in the volume. The diameter of the base of the cone is 10 centimeters, and its height is 4.77 centimeters. Hence, its volume is around 125 cubic centimeters. Now, the same cone is melted and a sphere is formed. So, the volume doesn't change. The radius of the sphere is 3.101 centimeters approximately, and hence its volume is around 125 cubic centimeters. Finally, the same sphere is melted.
ये देखो क्या इसमें दिखा है कि अब हम किसी भी चीज़ को कन्वर्ट किसी दूसरे में करते हैं तो वॉल्यूम उनका सेम रहता है। सेम रहने से हमारे यहाँ ना 13.3 एक्सरसाइज, हाँ वैसे ही उसी में ये सारे सम आएंगे। ध्यान से देखें।
And a hemisphere is formed, and so the volume remains the same. The radius of the hemisphere is 3.9075 centimeters approximately, and hence its volume is around 125 cubic centimeters. As you can see from the table, the volume remains the same even though the shape changes. Thus, we can say that when we convert a solid from one shape to another, without loss or wastage, the volume remains the same.
प्रॉब्लम देखें सम।
The dimensions of a gold cuboid are given. If 5 cuboids of the same dimensions are melted, how many gold coins of diameter 5 centimeters and thickness 7 millimeters can be formed?
हम देखें इसका में।
Let's consider the number of gold coins that can be made from the given 3 cuboids as x. Each gold coin is a cylinder. Therefore, the volume of all gold coins will be x times the volume of a cylinder.
देखो क्यूबाइड में से हमने एक कॉइन्स निकाल लिए हैं। कौन सी शेप में है? सिलेंडर शेप में। नंबर ऑफ
The volume of all the gold coins is equal to the volume of the given 3 cuboids. The height of the coin is equal to its thickness, and the height of the cuboid is equal to its thickness. We convert the units of the thicknesses of the coin and cuboid into centimeters. Next, put in the values of the dimensions in the formulae for finding volume of a cylinder and volume of a cuboid. Then we simplify. Thus, we find the number of gold coins that can be made.
तो ये थे बेटा हमारे सम जो हमने अभी किए। नेक्स्ट जो है ये था हमने जो 13.3 के सम थे। नेक्स्ट हमारा आ जाता फर्स्ट टर्म, वो हमारे अभी सिलेबस में नहीं है। ठीक है, आप भी इनको ध्यान से सभी करेंगे ताकि हम अपना डीजी का चैप्टर से ये अच्छे से 13 पॉइंट जो है वो ध्यान से। ओके बेटा, 13 पॉइंट जो है चैप्टर है वो कंप्लीट कर लें। ओके बेटा, हैव ए नाइस डे।